Good evening, everyone. So we are ready to start our webinar on the sewage and wastewater treatment technology in Sri Lanka, done by a veteran practitioner, Engineer Athula Jayamanne. So to commence the webinar officially, I would like to request our President of the Institute of Environmental Professionals, Mr. Premachandra Hakmanage, to give the welcome address and give a brief oversight on the selected topic. Over to you, Mr. Premachandra.
Thank you very much, Professor Hemanthi Ranasinghe. Good evening to you all. I assume that you all can hear me. Again, I think you all can hear me.
We can hear you, yes.
Yeah,
yes,
yes, thank you very
Go
much.
ahead.
Thank you very much, yes. As the President of Institute of Environmental Professionals Sri Lanka IEPSL, I have to welcome you. I have to give some introduction to the subject, and also I have to give you a very brief account of our institute. At the outset, first of all, I would like to welcome all of you on behalf of the Council and members of the IEPSL, and especially let me welcome our resource person, an eminent engineer and a reputed consultant, Mr. Athula Jayamanne, as our resource person in this evening to talk on this topic. And also I would like to welcome our moderator, Professor Hemanthi Ranasinghe, Senior Professor of University of Jayewardenepura, Sri Lanka. And also I sincerely welcome all participants from Sri Lanka and abroad as well. For this seminar, we have titled the seminar as Innovations in Sewage and Wastewater Treatment Technology in Sri Lanka. I really appreciate the logistical settings and coordination by our council members, Dr. Wahala, Mr. Prishan, our Honorary Secretary, Mr. Athugala, and our Executive Secretary, Ms. Cu.m. And also I really appreciate overall effort taken by Professor Hemanthi Ranasinghe to set up this important and timely seminar. And also I would like to appreciate the interest by Engineer Athula Jayamanne to join me at IEPSL and to share his experience and knowledge with all those participants. He is a reputed engineer and a consultant in the field of wastewater treatment, and several patents and awards he has obtained to his credentials in the field of wastewater treatment. Our moderator will give you a very, maybe a slight detailed introduction about our engineer, our resource person, Mr. Athula Jayamanne. If I talk a little about the subject, there are many examples where both surface and groundwater being polluted due to discharge of untreated wastewater from many sources, especially from industries and households located in close to water bodies and in environmentally sensitive areas. You may have a lot of experience not only in Sri Lanka regarding these problems, but also in many developing countries. As per guidelines and regulations under National Environmental Act, NEA, being enforced by Central Environmental Authority, which was established under the National Environment Act, Paraway in 1980, wastewater generators should minimize their wastewater generation. Actually, that's what we expect as far as green productivity, cleaner production principle concerns. Wastewater generators should have concerns to minimize their wastewater generation as much as possible, should treat and reuse their wastewater to the maximum level. As far as we concern 3R principles, we have to reduce, reuse, and recycle. This is very relevant to both solid waste and wastewater. We have to treat and reuse wastewater to the maximum level. And if you discharge, you have to treat to meet relevant standards imposed by Central Environmental Authority. And if you are going to discharge, you have to discharge to a designated points and purposes only, those being prescribed by the National Environment Act. Therefore, wastewater treatment and proper disposal is very, very important for industries who are engaged in many type of businesses, who implement a lot of various industrial processes. They have to think about their wastewater, they have to minimize, they have to treat, and they have to dispose according to the national norms and standards and regulations. Then only they can obtain required environment recommendations, environment protection license, and other relevant environmental approvals from many government bodies to run their business as environmentally friendly business for the sake of their business first, and for the sake of the society at large, and also for the economy of the whole country, and finally at very large stage for the sustainable development in the world. Therefore, this type of webinars is very important and will contribute immensely for environment conservation and protection through knowledge and experience sharing. And going beyond the topic, let me mention few words about our institute, IEPSL. Our institute, IEPSL, is the umbrella organization for environmental professionals in the country and established in 2006. By now, IEPSL has full government approval through incorporating by an act of Parliament of Sri Lanka. This is very vital. Now we are a fully legalized institute, well accepted locally and internationally. Our objective is to fill the much needed gap of having no professional institute for practicing environmentalists, to uphold the dignity and raise the reputation of environmental professionals in the country. Our institute is committed to extending professionalism and its service to the country at large for the benefit of the public. Our approach is to enhance ethical behavior. This is one of our major standard we are following. Always we are going to enhance our ethical behavior and its standards, contributing national environmental dialogue through credible, independent and scientific inputs. Environmental advocacy, extending professionalism, training and empowerment are major trust area of the Institute IEPSL. By now, we have 750 members, government, private sector, NGOs, academia, etc., including 80 chartered environmental professionals. We are following international levels standards and protocol when certifying professionals as environmental professionals. We are proud to say that we have produced more than 80 chartered environmental professionals, and they are doing very well both locally and internationally. We are doing a lot of activities, especially training, workshops in different subjects like environment management, environment impact assessment, and improving of environmental literacy of non-environmental officers in both government and private sector. We recently concluded 2 webinars focusing on new normal approach. Actually, that was very, very important and relevant because of this corona pandemic. We had to think about new approach of living, new approach of businesses, new approach of communication practices, and also achieving ultimate economic and environmental and social targets. And we'll be conducting our 13th AGM in January 2020. We have the focus this time, or otherwise our theme will be the importance of safeguarding the environment for national development. We have to always talk about the environment conservation and protection. There are many instances, both locally and internationally, serious contentious environment are happening and discussed all forums and everywhere in the world. Therefore, this seminar is very timely organized, and we have discussed among the council, and we decided to have this type of seminar, and we selected our eminent engineer, Mr. Athula Jayamanne, because he has expressed his interest to join environment professionals and to share his experience and knowledge. With these few words, let me conclude introductory remarks. And once again, I welcome all of you all. And I hand over the floor to Professor Hemanthi Ranasinghe, our former president of IEPSL and senior professor and forestry in the University of Jayewardenepura webinar. I wish you are a successful webinar. Thank you very much.
Thank you very much. Thank you very much, Mr. Premichandra. Actually, I really apologize for this little delay in conducting, in commencing the subject matter of the webinar, because Mr. Jayamanne really experienced the lightning in his own place, and so now you know, he has used a generator to get the PowerPoint ready. So thank you very much, Mr. Jayamanne, for that very timely effort. So you'll be able to continue with our webinar. Just a little bit about Mr. Jayamanne. I think he's a very well-known person. He's the Chief Consultant Engineer, Chairman of Eco Engineers and Company Global Private Limited. And he's a winner of many global awards, some being Green World Gold Award from UK, Green Apple Award from UK, and he has won Presidential Award several times and National Green Job Award several times, and Emerging Effluent Treatment Technology Award, Commercially Successful Inventor Award, and Sahasap Nimabiyum National Award for his work in the arena of biogas generation and effluent treatment. So he has, made country proud in the global arena, being a master in this biogas generation and effluent treatment technology. So we are very proud of you, Mr. Jayamanne. And he's also a registered environmental consultant in the Central Environmental Authority, and also a chartered environmental professional of our Institute of Environmental Professionals, Sri Lanka. So he will be enlightening us on the advanced biogas technology and wastewater and sewage treatment, with special reference to BiOUAFF technology in a variety of establishments that he has installed, spanning from hospitals, hotels, housing schemes, government offices, and also small houses. And not only in Sri Lanka, but he has established this in many overseas locations, India, Philippines, and Indonesia. So over to you, Mr. Jayamanne, to enlighten us on these innovations in this technology. Mr. Jayamanne, over to you.
Okay. Thank you very much, Professor Hemanthi, because First of all, I would like to pay my special thanks and gratitude for the Institute of Professionals, Institute of Environment Professionals, as that their effort to dispatch knowledge among our participants as well as among our other people, other interested people. Especially, I would pay my special thanks and gratitude to the President as well as to the Hemanthi and Dr. Sampath Balchandra and other office bearers. And first of all, I would like to go to the presentation. Then the presentation, you know that initially I would like to explain about the research work, what I have done during last few years to patent, to invent this technology. Actually, due to some heavy thunder, maybe you should not hear some part of my speech. Then in research, about 15 years back, I got when I was working at National Engineering Research and Development Center as a senior research engineer, I went to India to have a small training on biogas. On that, I studied about the anaerobic filter technology. Actually, there also in that time, it was in the laboratory scale. Then I studied those things, and all units were vertical. For example, that anaerobic filter, which can use for digest wastewater and clean wastewater, all the units are vertical. Then, but constructing vertical units are very difficult in Sri Lanka. Then, because of that, initially I did a horizontal unit here, one of milk dairy industry, the Michiko yogurt factory. This is that one, and this is the inlet of that wastewater. And inside the top, you can see the water seal, and inside the bacteria filters are there. Then in those bacteria filters, we grow anaerobic bacteria, and once that wastewater drives through those anaerobic filter bacteria, then all the bacteria consume that nutrient of the wastewater, and ultimately at the end of the system, we can obtain the treated water. Then later on, I have did another research for a desiccated oil mills where that very heavy pollution level was with the wastewater. For example, the COD level of the wastewater from a desiccated coconut mill is around 40,000 milligram per liter. And then initially I construct this small digester, underground digester with the bacterial filters, and those bacterial filters work well. And ultimately it gives some good results with the small amount of water. Then later on,
Athula, I think we cannot see your presentation.
Is that? Just a minute.
Yes, yes. I think you have to connect. Go to the share the presentation. Otherwise, nobody can see.
Okay.
Trishan, please try to share his presentation. Please help him. Oh, okay, now. Okay.
Okay. Now you can see it, no? Is it okay?
Yes, perfect. Perfect.
Okay, perfect.
Right. Then in my very initial research work, I did digesters with the help of PVC tubes. The PVC tube used as a small digesters, and I did some small research work for the wastewater from desiccated coconut mills. Those wastewater from desiccated coconut mills having a very high pollution level. For example, COD level is between 40,000 to 50,000 milligram per liter, and BOD is around 25,000 to 35,000 milligram per liter. Then with this one digester, I achieved some results in the mill. But in the laboratory with 3 digesters, small scale digesters with the Echelon pipes means with the diameter of 8 inches Echelon pipes, I achieved good results. For example, actually those results are just matching the requirement of the Central Environmental Authority. Then I published some international papers in different universities. Then I got a scholarship to do my master's in AIT with that publications. And at that time, there are World Bank funds also at Nerd Center. Then I went to AIT for do my master's. Then my advisor asked me to do this same research to improve my knowledge. And when we are doing, for example, then this is the research which I have done in AIT. Then all digester constructed with this PVC tube like this. Then inside those PVC tube, the bacterial filters are there, the anaerobic filters. Then first there I use pig done as a raw material, as a raw wastewater. Then first of all I took the pig done and mix with the water and pour it to that inlet chamber. Then it goes to the digester, bottom of the digester, and it comes up and goes to the next bottom of the next digester and comes up through the bacterial filters, and again it goes to the bottom of the third digester and comes up with the bacterial filter through the bacterial filter, and ultimately we can have a fairly good water. Then my professor, here you can see Professor Lee, and he asked me to build a pilot level, it's not a pilot level, the bigger level of bigger scale level in a piggery. Then we went to a nearby piggery and installed these 3 digesters with the help of gherkin barrels. First digester, second digester, and third digester. And we obtained the gas and we obtained the final treated water also. And my whole thesis with this research, and later on that AIT staff sent me to the Sri Lanka again to get the data from my research which I have done at Nerd Center with the help of what's called that coconut wastewater, that desiccated coconut meal wastewater as a raw material which we used. Then after that, we have a good results. And once I returned to Sri Lanka after my masters, I have constructed these 3 digesters. First digester, second digester, and third digester at the desiccated mill at Ratcharavu. And with these 3 digesters in full-scale units, we couldn't achieve the real standards. Then I have to think about another option. It is called facultative bacteria. Then we have constructed facultative bacteria tanks. Then all those tanks having a bacteria filters inside, and once that wastewater goes through all those bacterial filters, after anaerobic filters, then ultimately you are getting the treated water. And that gas, again, there are considerable amount of gas came out from the digesters, and all those gases we collected through those pipes and feed it to the boiler. And we can have a considerable saving of fuel in the boiler. And later on, once I returned to Sri Lanka, I have a number of opportunities to have a wastewater treatment system. One is the Sri Lanka Distillery Private Limited at Vaduva, and the wastewater amount is around 30 cubic meter per day. That means 30 cubic meter per day, and to again the COD level is between 40,000 to 50,000, and it is so acidic also. Then we have to construct 6 digesters in series like this. First we feed the water to this digester. You can see the feeding line here, and it goes to the bottom of the digester, and again second, third, fourth, fifth, and sixth. Then after that, it goes to the facultative tank. And it emits huge amount of gas also. And that gas we utilize in the boiler. And you can see the biogas flame inside the boiler. Then actually that boiler works with the biogas as well as the firewood also. Then there's a considerable saving of firewood. Then if I show some cross-section of the digesters, it is like this. The outer walls, sometimes we can do, if it's a small one, we can do it out of brick and cement with the concrete skeleton, or we can do it totally RF concrete, reinforced concrete. And inside, we can see the bacteria growing media, that BGM, bacteria growing media. And the wastewater goes to the bottom, and it goes up very slowly up to the top. And at the top, it goes to the second one. Like that, it goes to the third one or fourth one, according to the amount of, actually the design, depend on the number of digesters. The number of digesters again depend on the how much of wastewater we are getting and what's the COD and BOD level of that wastewater. And after the digesters, it goes to the facultative tanks. The facultative tanks, like there is a series of tanks, and initially it enters to the first tank and goes to the bottom of the tank, and again it comes up through the bacteria growing media, the bacteria filter, and goes to the second one, like that. It goes to the wastewater, goes to the bottom and comes up with the filter, and again goes to the bottom and comes up through the filter, and like that it water goes in zigzag flow like that, and it's all through the bacterial filters where that facultative bacteria is there. Actually, the facultative bacteria is it's some sort of we call mixture of bacteria or cocktail of bacteria. It's having anaerobic bacteria, aerobic bacteria, and at the mid we are having facultative. Facultative means it can live with oxygen or without oxygen. Then that bacteria can utilize the final sediment, that final water from the final nutrient from the anaerobic digesters. Initially we are having anaerobic digesters, but anaerobic digesters can utilize only 80% of the nutrient, and further to that it produces ammonia also. Then that ammonia and 20% of other nutrient will be absorbed by the bacterial filters here in the anaerobic, here in the facultative bacteria tanks. Then ultimately you are getting the treated water, but at the end we need to have a gravity sand filter to retain the suspended bacteria. Actually, with the gravity sand filter, all the suspended bacteria trapped in the sand, and after 6 months or 8 months we have to replace the sand once it gets clogged only. Then we are having number of applications. I would like to show those things to you all. And after that, the treated water has to be again disposed in some, according to the standards of Central Environment Authority. We can use those treated water for the agriculture, or we can release that treated water to a water body, natural water body. But if you don't have agricultural land or natural water body means it should be a fairly big one, because the dilution factor would be 1:8. That means if you are releasing 20 cubic meter or 30 cubic meter, 20 cubic meter of water to the water body, the water body should have to have a flowing of 20 into 8 times. That means 160 cubic meter of flowing should be there. Then in most of the places, such things are not available. Then we are using some landscaping area. For example, is this the landscaping area? Then we are having a pipe network like this. The one central pipe is going like this, and another branch pipes are like this with the approximately 8 feet in between centers. Then those pipes we laid like this, that first of all we cut a dig with the depth of 4, cut a trench actually, with the depth of 4 feet. And we filled with, we filled the 2 feet. First of all, we filled 1 feet with the 3/4 metal and lay the pipe, perforated pipe. You see that pipe having a small perforated line, holes. And again, we filled the balance 1 foot with the 3/4 metal. Again, the other 2 feet will be filled by the normal soil, whatever the excavated soil during the excavation of the trenches. Then once we send the water to this line, the centralized line, it delivers those branches and all those areas filled with the treated wastewater, and it absorbs to the ground. Actually, treated wastewater doesn't pollute the ground because the treated water should have to have a BOD level of 30 milligram per liter and COD level of 250 milligram per liter. Then that is the standard given by the Central Environment Authority, and we have to again control the E. coli also. To control the E. coli, at the end of the sand filter, we are having a chlorination system for the treated wastewater. And I will show some number of applications. This is one Poltex garment factory with the 400 girls, 4,000 girls, and their wastewater output is around 100 cubic meter per day. And here we are having about 1, 2, 3, 4, 5 digesters and 1 facultative tank. And again, this is Maria Hospital in NEGOMBO, 1 digester and another facultative tank. And this is Dunaga desiccated coconut mill. There we need to have 3 digesters and after that facultative bacteria tank. You can see the sand filter at the end. And here collection tank of the treated water. At that treated water, they are sending it to this banana plantation, like that. And here the Sri Lanka, that Rockland Distillery, Marawila Distillery, and they are, these are the digesters, and it emits huge amount of biogas as that spent waste. That means that after distillery you are having a spent, we call in Sinhala, it's called Boda. Then the COD value is around 60,000 to 70,000. And BOD also comes up to 40,000. And huge, due to the COD, high COD and BOD, huge amount of biogas comes out from the system. And during the night time also it emits. Then to collect the nighttime gas, we are having a gas holder here, gas holder. This is a floating drum gas holder. And during the night time it fills up to here. It comes up, the internal holder comes up to here. And during the daytime, we are using that old gases to the boiler here. This is a dual foil. I converted it to a dual foil boiler. This is the gas line, and this is the diesel line. And at that time, that is about we did this system about 10 years back. At that time, the diesel saving per day is around 35,000 rupees per day saving. And this is another Veerasiri Cafe, Kottawa. There we don't have a place to construct the digesters, but the wastewater output is around 30,000 liters per day. Make a balance. 30,000 liters per day, and because of that, we need to have 3 digesters with a huge capacity. Ultimately, we did the digester inside the kitchen. We remove 2 walls of the kitchen and drive the excavators inside. And this is one mouth of the digester, but this goes about 20 feet down underground. And we use it for housing schemes also. This is Angulana Housing Scheme with 288,000. We constructed 4 digesters, 5 digesters, 1, 2, 3, 4, 5 digesters at the backside of the housing scheme, and another facultative tank also available. And the treated water we are leaving to the Angulana Lagoon. And this is one report in Angulana Housing Project. You can see that after treatment, BOD level, biological oxygen demand level, drops down to 24. The COD level drops down to 54. The requirement of COD is 250, but it drops down to 54. And TSS would be 5, but the requirement is TSS should be less than 10. You can see the very good results we have achieved with this system. And Hotel Eden and Spa at ALUTHGAMA also is having 160 rooms, and it's a 5-star hotel. And this is the operation engineer there. And I did these digesters, and ultimately I have shown it to the normal laborers while drinking the treated water. But all treated water comes from the sewage and bathing water. And this is another application in GRANDEEZA Hotel NEGOMBO. As they don't have enough area to construct the system, I have to construct all the systems underground. Then you can see here some paving blocks. Then my system is totally underground under this paving box. And at the top, we are in the car park. And there are a number of underground applications we did. This is another Amari Gold Hotel. And Mr. Bob Kundamal, chairman of Lanka Construction, he is the client. And he, first of all, he attended to my presentation, and initially I did a small unit for a small scale system for a small housing scheme under for the construction of his construction. And later on he did this Amari Gold Hotel, and here also our system is totally underground. Here some manholes are available to install the bacteria filter at the beginning. But in some cases we lay the paving blocks on the top of the manholes also. And here another hotel, that Rio Park Hotel at MATALE, that total wastewater output is 130 cubic meter per day. And this is housing complex at Norachole power stations at Karamba. And there what was happened when the Chinese doing the Norachole power station, they did the housing scheme and wastewater treatment also. But that wastewater treatment system having having about 27 aerator pumps and other pumps, other sludge and feed pumps. But in my system, only then they call the tenders to repair the existing system, because after 5 years that all pumps went wrong, and lot of switches and that panel boards available with the control room, that all switches and circuit breakers went wrong. Then they call tenders to repair that system or propose some remedial system. Then I proposed my system. Actually, cost of my system is less than the repairing of that existing system, that old system. Then they have given the tender to me, and I construct these 3 digesters and facultative tanks. Now it is working well. Now it is more than 5 years. Then afterward, very recently, they are constructing another house scheme at Daluwa near Norachole for expansion of the power power station. And that tender also, once that they also asked me to put the tender for that construction of the wastewater treatment system, that my tender was the lowest actually, and we have already given the construction, we have already started the designing part of the system. And here another housing scheme at LUNAWA, I think actually that total construction of the system belongs to a State Engineering Corporation. Even LUNAWA housing scheme also belongs to State Engineering Corporation. When the State Engineering Corporation call tenders, then I put the tender and my one is the lowest and they select my system. the major advantage of this system, I will then tell you later, there is no maintenance and no requirement of electricity during the process. Only feed motor is, only one motor is enough to feed the wastewater from the collecting tank to the system. And this is a household biogas, and if you need to have a household scale, even this is in my house, actually it is inside the kitchen. As I don't have enough space at the back side, I construct the system at the inside of the kitchen, and you can see the mouth of the digester only. And this water actually, this is not the wastewater, this is the water sealing actually. Once we have this type of mouth, then we are having a clay sealing with the concrete lid at the bottom. We are putting the concrete bottom, means bottom of the cone. We are putting the concrete, small concrete lid, and to stop the gas leaks, we put on top of that lid the clay and cement. Then to refrain the cracks of cement and clay, we put some amount of water there. Then we have to, the only maintenance of this water level. If that water goes down due to the evaporation, or sometimes here in my house some dogs try to drink those water, then I have to top up the water. But in that huge system, we are having a separate supply of water to top up the water of the mouth. And you can see this is my kitchen biogas unit. And you can see the flame. Even this photo was taken today. One that Professor Hemanthi asked me to, you should have to show you that household unit also. Then I took 2 photographs and add to this one. And cost of this system is very less. The material cost would be around 1 lakh, and that can be supplied by the client. And construction cost of our masons would be around another 80,000 or something. You see that once you have this system, you don't need to have a septic tank, and you don't need to have use gully houses, because ultimately you are getting the fully treated water, clear water. Once you put that clear water to your soakage pit, we need to have a small soakage pit. It doesn't clog the soaking nozzles, because in soaking pit you need to have a soaking fountain. No, not the input fountain, soaking fountain. Then in normal 3-chamber or normal septic tank system, the water goes to the final soakage pit with the suspended solid. Then those suspended solid, after maybe 2-3 years, clog the all soaking areas of the soakage pit. Then after 2-3 years, it's starting overflowing. Then you have to hire a gully bowser. Then most people hire a gully bowser, and next day onwards, they put again that same water to that one. That means same water with the suspended solid. And that water goes to again that fully sealed soakage pit. It is not a soakage pit at that time. All the soaking areas was clogged with that suspended solid. It turns down to a flame type layer. Then at the second time, it will top up within 6 months or 7 months. Then every 6 months or 7 months, you have to empty the thing while hiring a gully bowser. But in our system, we, for example, in this system, I have constructed about 15 years back. So far, I never used any gully bowser during last 15 years. And this is the cross-section of the household unit, and this is the inlet gully, and the sewage and kitchen wastewater lines can be connected to this gully, and water goes to the bottom, and we are having a mid wall also, and that sewage and kitchen wastewater goes to the bottom, and day by day, once it feed in through this wastewater and kitchen wastewater and the sewage, it goes up and past the top of the wall, intermediate wall, and goes to the bottom again. Actually, the wall is not to short circuit the system. Otherwise, without this wall, the wastewater inlet is here, outlet is here. It can short circuit from here to here. Then to refrain from the short circuiting, we are having intermediate valve. Then ultimately it goes to this is called pressure tank. Actually with this, we have to maintain the pressure of this biogas outlet. And that outlet water, we can put it to the socket pit. And this is another Environment Ministry building we did at Battaramulla. This is the digester and socket that faculty to pond also, faculty to tanks also, and underground. And another prison complex at Angunukolapalessa. And these are the three places we have done digester here. This is some aerial photo we took from the Google, and these are the digesters, and we have 3 HTP systems for this Angunukolapalessa prison. And currently we have completed in India 16 projects for the, especially for the desiccated coconut mills, but very so far we have completed 16, but currently we are on construction. Actually we couldn't go there now, but we have sent the bacterial filters and other associates to India. Already they have paid the money, but we couldn't go due to the this corona problem. And we have started one, we have completed one project in Philippines and another one project in Indonesia. And you can see this, the one India project under MAHAVIR coconut, and that MAHAVIR coconut company having 3 mills. All 3 mills were done by myself, and this is the second mill. And the treated water, they send it to the nearby coconut land to feed the to irrigate the coconut land. And the treated that biogas they utilize, because all the DC mills having oil traps. The DC mill wastewater consists with lot of oil. Then that oil can be trapped in oil trap tanks. We call grease traps, and all oil traps having a forming of top scum after a few days. Then that top scum collect and put it to the very big pans, and with the help of biogas they boil it, and they obtain non-edible low-grade coconut oil for the low-grade soap manufacturing, and it is sellable again. And actually the Pollution Control Board of India in Karnataka, they are very happy with my system. And the Pollution Control Board means that it is almost similar to our Environment Authority here. And they conducted 3 seminars for the expose my technology among the, especially among the DC millers, because they don't, so far they don't have any solution to treat the wastewater from desiccated coconut mills. Here in one seminar, this is the Professor Chakravarti, the chairman of Pollution Control Board of Karnataka, and his presentation. This is my presentation, and this is the chairman of MAHAVIR Coconut, Mr. Arun Kumar's presentation about his successful story. Actually, that was conducted after completing two wastewater treatment systems for MAHAVIR coconut. The first one they did after visiting Sri Lanka and visiting my projects here, and they monitored that first system for a period of 1.5 years, and after that they started second one. Once we are doing that second one, this Professor Chakravarti arranged this seminar for the DC millers. Here you can see the DC millers. And here one what we did in Philippines for the Tree Life company, and here another in Indonesia, where this is called Sofy Agro, desiccated coconut milk in Indonesia. And another very big problem comes out with the palm oil mill at Nakia. The wastewater from the palm oil production is highly polluted. The COD level is more than 100,000, and BOD is nearly about 80,000. and it's having a lot of oil also. And to remove the oil traps are not enough. We have to have oil ponds. Actually, it is another research what I have done, and it took more than 2 years to complete the project. And there are a lot of difficulties, lot of bottlenecks there. Then I have to overcome all those problems. These are ultimately we have come to our final end with success. And here you can see the 4 digesters totally underground and with the capacity of 200 cubic meter. And you can see the biogas output. The flame length is 12 meters, is very wrong. It is about 8 feet. The flame height is 8 feet and 24 hours continuous. And due to this works, I received number of awards. Recently, I award in 2018 Green World Award from England, and I was selected as a gold winner, global gold winner. Actually, there are only few gold winners selected for this competition. About I think 500 applicants were there from all over the world, and we were selected as a gold winner. And in 2015, from UK again, I get the International Green Apple Award. From actually the ceremony was held at London Parliament, but in this competition, they considered my projects and they collect the data of my credits, and they just telephone to most of my clients in India and as well as in Sri Lanka. They took their what's called acceptance and took their views about my system. Then afterward, they select me as a Green Apple Award. And in Sri Lanka, I get the President Award in 2009 and National Award in 2009 again from the, at that time, Environmentalist is partly jumping and Agriculture Minister is Mr. Maithripala Sirisena. And again, I took the National Award from 2010. Afterward, that National Award Committee asked me to not to apply again. Otherwise, we have to give every time. Then I never applied after that. And again, I got another award from in 2012 as the most commercially successful inventor. Actually, the according to the actually this one conducted by Inventors Commission. According to the Inventors Commission, the maybe around 5 to 10% of the inventions will get commercialized. You can have a number of inventions, but very difficult to put it to the society. That our inventions actually, for example, in my, I am having 4 patents for this wastewater treatment system, and again acidic wastewater treatment system, and again application of biogas for the diesel engine to operate the diesel generators. But the wastewater treatment system is the most popular means it is the system adopted by the society. Other systems are not much practicable. For example, we can use biogas for the power generation, but to use the biogas for the power generation, we need to have a huge amount of biogas. But in such a situation, where that, for example, in Nakia oil mill, there is a huge amount of biogas. But instead of power generation, it is very well to utilize in a boiler. Like that, then there is no chance to utilize that technology, utilize that patent for the power generation, like that. Again, and for the presentation in Knowledge Management Seminar at Kathmandu, as a Advanced Technology on Biogas Sri Lanka, that my presentation, I got an award. And there are a number of I was selected for a number of presentations to present my technology in international level. One is World Renewable Energy Congress in Florence, Italy, and International Conference Knowledge Management in Southern Nepal, and the World Renewable Energy Congress in Jakarta, and one Conference Energy Sustainable Development in Cairo, Egypt. And in India, actually very beginning, they search where that who is the person who invented. Actually, they search about the technology for the treatment of coconut wastewater. In 2012, they went through my website and they invite me to conduct a seminar in Bangalore. With the invitation of Pollution Control Board, I went there and I conducted those seminars. And there also at that time the different chairman, and he also gave an award for me. And after that, we start the construction of wastewater treatment system, application of wastewater treatment system in India. That is the initiation. And these are the advantages of our system. No power consumption. Most of the wastewater treatment system needs to have a considerable amount of power to operate their aerators, to pump their sludge pumps, to pump their other delivery pumps and like that. But in my system, only one feed pump is necessary to feed the wastewater from the collecting pit to the system. And no sludge generation, the second, actually no need of sludge, management. In other cases, in other systems, there are a huge amount of sludge comes out, then some sludge reverse systems are there, then some sand beds for the sludge management are there, then a lot of sludge management system should be there. And we are giving 25 years warranty for our bacteria growing media. There no any company giving such a warranty. Because I have done my first reactor in 1996, still the system is working. Now it is already 24 years old. And very least maintenance cost. There is no other maintenance. You know that I have to maintain top water, that mouth water, and chlorination only. Dripping, it can be done with the dripping of the chlorine water with the help of a barrel and tap. And the other advantage is it produces biogas. And ability to treat in combinations. Combination means, for example, when we consider about a hotel, it is having a sewage, it is having a bathing water, it is having kitchen water, and it is having laundry water. Lot of different wastewaters are there, but we can combine all those things. We can mix all those things and treat it. And zero odor and noise. Zero odor means that our all digesters are fully closed down. Then because of that, there is no odor comes out, as those things are very sealed on. And no noise also, because noise mainly due to the aerator pumps and other pumps, but no noise. And space is not a problem. If there is no space, we can do it totally underground, and top area we can use for a landscaping, or we can use for a car park, or we can use for any other purpose. And long non-operation period acceptable. That means that I have told that, for example, when you consider about the desiccated coconut mills, during the very less yield period, that means between November to January, February, they have to close down the DC mills due to the very less yield of the coconut. Then once it shut down, the bacteria doesn't have feed, doesn't have food to eat, but it slowly turns down to the hibernated position. Then after 3 months, once we send the water, again that wastewater as a feed to the bacteria, it walked up from the hibernated position and start to working. That is the special ability with this system. And able to operate simultaneously means that once for example, in Hotel Eden, they had the system of very old system called with the aerators, but it's not working. It's partially working. It's treat the wastewater very partially. Then while it's operating, we construct the digesters and feed the wastewater to the digesters, and again it emits the water partially. partially treated wastewater. Then that old tanks we utilize as a facultative bacteria tank. Then we empty the old tanks and fill with the bacteria growing media with the facultative bacteria and connect up them. That means without closing the hotel, in Hotel Eden and Spite, what's called not Angulana, that ALUTHGAMA. They once they call for the tenders, there are a lot of tenders comes out, but every tender asks to close the hotel for 1 month or 2 months. But I did the system without closing even 1 minute. With that ability to operate simultaneous condition. And actually, I would like to wind up my presentation. If you have any questions, then you can ask from you can ask the questions, and with the help of me power unit again, power unit gahalane me battery low
battery low oh my God. Okay, thank you, Mr. Jayamanne. That was very elaborative and knowledgeable, knowledge producing presentation. So thank you very much again on behalf of the Institute of Environmental Professionals and the audience which gathered today for sharing that very topical and very innovative technology. So I'm sure there would be many questions, although the time is a little, running out on us. But we would like to request the audience to ask any questions that you like from our resource person. So you can unmute yourself when you ask the question.
Can I ask a question? Just a clarification.
Yes, please go ahead.
Yes. Athula, I am Jayewardenepura. Just to know, I mean that since you are dealing with production of or the generation of biogas, how do you ensure the safety now? Since through your presentation, we saw that sometimes most of the biogas units, your construction are below the ground. So how do you ensure the safety over a long period of time since you are dealing with, I mean that the biogas is a very kind of, just a clarification from your side. Thank you.
Mr. Jayamanne, you have to unmute your.
Yes. Please unmute.
Mr. Jayamanne, you have to unmute. Yeah, you have to unmute.
Okay, no? Right. Then actually the main advantage of this biogas is it is not explosive. But LP gas is an explosive gas and it's a heavy gas. If you have any leak inside a kitchen, if you have closed the doors and windows with the LP gas, it's stored in the, due to the leak, it's stored in the same room, that kitchen. And once you light up box of matches or whatever, any lighting, then it got exposed. But as the biogas is a lighter gas, during the leaking, it goes up and up from the ceiling or from your roof, it emits to the environment. Then there is no storage of biogas. For example, during during the history of biogas, no explosion was recorded. Then that is the main advantage. The leakage mainly actually we have to control with the, for example, if the burner is not working, then we have to check the leaks. Then if the system is not emptying the biogas, then we have to check the leaks. Then like that we can do the leak checking, but there is no danger of the leaking. That is the main advantage of the biogas.
Hello. Hello.
Yeah.
I am Premchand. I am Premchand asking simple question. At the beginning, you said that vertical anaerobic system doesn't fit to Sri Lankan conditions. Why is the reason? Vertical
No,
anaerobic
that
system.
no, the thing is this actually. Initially what I learned from the India, they installed the vertical Eslon tube on the top side. And my professor showed me some vertical anaerobic filters in Europe. But those are very tall, about 30 feet, 40 feet tall. Then if I going to construct such a tall system, then it is a very huge cost to the client because it should be totally reinforced concrete. Then what I did was, instead of having that earlier I did a horizontal one, but it works. But ultimately I decided to have a vertical one. You can see that we are having a number of digesters, but it flows in vertical. Instead of 30 feet height, we have three numbers of 10 feet height digesters. You see, then again the flowing is vertical, not horizontal. But it goes zigzag flow. Goes to the first one, as I have shown, go to the zigzag flow.
Okay, thank you very much. Thank you. Thank you, Athula.
Okay. Right, okay.
Any other questions, please?
Mr. Athula, can you hear me?
Yeah, of course.
Right, okay. Normally, anaerobic, normally anaerobic treatment plant, it is very sensitive for the pH and temperature as well as toxic. So also if the system collapsed, normally we know the startup time for the anaerobic treatment plant is very slow. It needs some conditioning things. If the system collapses, like a toxic entry or like pH changes or something else, how we can overcome very quickly? How we can overcome?
Actually, that if you have an acidic wastewater only, you have a problem with the pH. For example, when we think about the wastewater from a desiccated coconut mills, and when we think about the wastewater from a distillery, those wastewaters are very acidic. Then we should have to have some pH correction system. Then normally what we are doing is put some chemicals like caustic soda or lime, calcium carbonate to neutralize the pH. But about in 2009, in 2009, I invented a new system without using any chemical. There is a pH neutral system with the feed mode only. And I have patent for that, and I got the 2009 Presidential Award for that patent. Then you don't want to worry about once the system operates automatically while correcting the pH. Then there is no problem with the pH. Again, temperature here in Sri Lanka, we don't have very cold temperature. The current temperature doesn't have any problem. Sometimes in our very beginning work, we don't have that pH control system and we have problem of control. And at that time, actually, again, we have to apply the bacteria and it takes time, of course, it takes time. But in current condition, in Sri Lanka, we have completed more than 30 desiccated coconut mills. In India, we have completed more than 16 coconut mills. And all are working without any problem. Yeah.
Okay, thank you.
Yeah.
Okay, Mr. Jayamanne, I have another simple question. I'm Premchand here.
Yeah.
Hello.
Yeah, tell me.
Can we run this type of plant using sewage only? Complete sewage. Can we run this type of plant?
It doesn't matter actually. Sewage is very simple to treat. The other wastewaters are because sewage doesn't have acidity. The pH is around 7. Then again, sewage doesn't have too much of oil. No need to have oil traps. And for example, in my house, we are directly send my sewage and kitchen wastewater to my biogas unit, and I am getting the biogas for my cooking. And while it treating the water, but it doesn't need to achieve the standards of Central Environment Authority, as it's a domestic one, we need
Yeah.
not to have a facultative tank. Only digester is enough. Any
Okay.
type of sewage is very simple.
Yeah. Okay. That's nice.
Yeah.
Yes, I'm Sujiva from Ministry of Environment. So I
Yeah.
think considering the land area and the cost of construction, I think this is a maintenance. It's a very successful system. And in our ministry, of course, depending on the quantity of waste that is very low, and so therefore there's no biogas generation. And in introducing this system and popularizing, now we had a recent discussion with the water board, and they say there are some limitations in introducing this to all the areas of the country, and especially in the cities that this can be recommended for the suburbs, and there are some limitations. So what do you think about this?
No, actually, in my system, I have widely used in urban as suburbs also. For example, in Karamba, number of housing schemes in Karamba, I have used my system to treat the wastewater. And again, in suburbs also, there are a lot of, for example, desiccated coconut is totally in the suburbs, no?
Now, sewage treatment is a huge problem, and it's very highly costly.
You talk about the waste treatment, not the wastewater, no?
Yeah, waste treatment. Yeah, sewage treatment mainly.
Sewage treatment. Yeah, sewage treatment. Yeah.
Because sewage treatment is a very costly thing, and now because the sewage systems are so expensive that normally the sewage is not treated. So most of the waterways are contaminated with sewage now all over, and we have a lot of algae blooming and all. So I think we need to popularize, because the cost is the issue. Therefore, if we can popularize this system wherever possible, I think it will be helpful, and we can, regarding the health concerns and environment, I think we need to take some steps to popularize this. No, that should be done, I think.
Yeah, actually, that was mainly happened due to the gully house owners. There are gully house private owners are there. Then they suck the wastewater from the tanks. You mean the septic tanks, and they find some forest area or some non-man area. Then they release the water to those places. Then due to that, it gets polluted. But some gully house, for example, in Goal, one gully house owner wants to, that he has already get our proposal and forwarded to the Central Environment Authority, and Central Environment Authority also recommended it as a good example for the other gully house private people. And there he has a 5-acre land of cinnamon, and he's going to have our system and treat that 5-acre land of cinnamon with the treated wastewater.
Now the gully houses are just empty here and there.
That's the problem.
Proper system to dispose gully houses. So
System to definitely.
Athula, just a clarification from you. I mean that once again I'm Jayewardenepura and from CEA. Do you have any do you have any plans or some kind of research going on to apply this system or some improved version to address the issue of leachate coming from normal what you call the MSW because of the garbage?
We can treat the leachate, because leachate doesn't have too much of a COD. It's having a COD level of sometimes maximum 40,000 to 50,000. But our desiccated coconut meal wastewater also like that, and leachate doesn't have oil and grease too much. And if you have a chance, then we can apply it for definitely. Actually, that Muthurajavela, they had already asked me to invite and send a proposal. I have did the thing, but so far no work was started. Because Muthurajavela dumping yard having a huge amount of leachate, and it just flows through the ground and it goes to the nearby lakes. Even I don't know whether it goes to the Hamilton Canal also.
So what you I mean that tell is that there's a possibility of using this technology to address the leachate coming from what you call the
garbage.
Management. Yes, garbage from the garbage.
Yeah, definitely we can treat it. There is no issue.
Thank you.
Mr. Jayamanne, actually, you talked a lot about the technology at various levels, various magnitudes. I have two questions actually. One is about the household. You showed this your own household biogas reactor. So the misconceptions that we have is that you know, when we mix our kitchen and the toilet, due to the use of detergents, whether you know, we could use that as a proper input, and that's number one. And also, supposing if we are going to install a household biogas reactor, what would be the minimum feedstock that we have to generate per day, and how much it will cost, and also what would be the maintenance? How would we can maintain the system? That's one thing. And another thing is that we have seen in many schools and other public places, the biogas generators had been installed, and maybe from various international and national projects. But most of the time, you know, after some time, they are not working. Maybe because they are not being, you know, used properly, not maintained properly. But anyway, people lose interest because the biogas generated becomes very little, and then it doesn't work. And when they try to get the technical assistance also, it is difficult to get. So all these problems are there. So can you, you know, give your views on these things?
Yeah, that initial question is about the household units. Actually, that household units, once you have the detergent, then I will give one example. If a 4-member household, one member normally utilize 30 to 40 liters per day for a as a sewage. Sewage means that you have to go to the night soil for one time, and for the urination another 4 times or like that. Then once you flush it with the water, it goes the total about nearly 40 liters per day. And if the 4 members, it is 160 liters per day. But how much amount you are putting as a detergent? Maybe 200 ml. No? Then 200 ml diluted in 160 liters. Then that means you are having 1 spoon of whiskey and 1 glass of soda. No effect. No, you are not getting effect from that. Like that, the bacteria also not getting any effect with that huge amount of dilution. But there are a number of other cases also due to the failure, especially the structure. That there are a lot of normal masons, they do the biogas units without having a proper concrete structures, because you mean totally out of brick and cement. You can't have a total out of brick and cement biogas units, because after a certain period, it's having a very minor cracks. It's because with the minor cracks, it starts leaking, because it should be a gas tight one, not a watertight one. And gas tightness of the dome also depend on the mason. Then in my case, I have developed a special chemical to gas tight the dome. Actually, inside the dome, we plaster with that chemical. For example, for the Indian construction, in India, I have to export that chemical to India, because it is not available anywhere. Then, but most of the masons, they applied number of layers of plasters, 1 layer, 2 layer with the cement and lime and like that. Then, if the mason is not much skilled, then domes start leaking. Then it produces some amount of biogas, but half of the gas only you can utilize. The other half went away with the leaks. Then, if the structure is not so strongly built, then it have minor cracks. Again, it leaks. Then these are the main reasons to fail the domestic level biogas units. But the big digesters, if you have especially managed with the sewage and wastewater, For example, I did my first digester in 1996, the Ratkarao DC mill. Still the digesters are working. Still the system is working without any problem. But even that level, I have to say that it is not a perfect structure. Then later on, we improve that structure further. Now, for example, currently we are doing a Mayangane base hospital wastewater treatment system. It's a huge system with the amount of 270 cubic meter of wastewater and total digesters out of reinforced concrete. All the digesters that like that depend on especially household unit. The Bason has the masons, they are doing totally out of brick, and sometimes they use 4-inch brick pole. Then those things are not enough. That is the especially among the household level, that was not successful, as the number of small masons are doing without any design.
Okay.
And,
For you to...
and the cost of our domestic system is, I told that material cost would be around 120,000 because it can be supplied by the client, because we can give the material list to the client. There are like 10 numbers of digesters, 10 numbers of cement bags and 3,000 bricks and 1 cube of sand. Like that, we can give whole material list to the client. Then client has to supply the material. Then one of our skilled person can go there with our design, and he will build according to that design. And we can complete the unit within 200,000 rupees. But the payback, you see that if you have 5 members of house and the total sewage and kitchen wastewater from a 5 member is enough to produce the biogas to cook their meals. Then that means for a 4-member family or 5-member family, per month you have to utilize at least 1.5 LP gas tanks, no? Then it would cost about 2,500 or I don't know, 2,200 or something. Then within 10 months, you can have a recovery of 2,000. Like that, 1 lakh, in 1 year, it is about nearly 300,000. Then within maybe 10 years, not the 10 years, within about 20, 25 years, you can have the recovery. Payback. And no need to hire the gully bowser. That is the main advantage. No need to hire the gully bowser.
And what's the volume of this 200,000 investment?
Yeah,
what would be the volume?
Yeah, it is. In my my presentation, the diameter is around 5 feet and height of the cylindrical part also around 5 feet. Nearly it's about 5 meter cube.
Okay, thank you very much, Mr. Jayamanne. So, these digesters in schools also, I mean, with the technology that you have, I guess the main issue is that there has to be someone who should maintain it and who should have a dedicated person to maintain it. And also, when they need help, technical assistance, I mean, it should be available, no? I mean, how do you think, you know, it would be done? Because that's what the main problems in operationalizing these systems in schools.
Yeah, especially the public system, what I have learned is
so with
that,
your system,
at the beginning, Hello? Just tell me.
Yes, we can hear you.
Yes, that in most of the public system, one interested person start the thing. Then after once he left the place, then another people doesn't want to look into that one even. Then, for example, we have to maintain the top water level. No, if it that water evaporated totally, the clay ceiling get cracks. No. Once it cracks, no gas, no digest, no output of the biogas. Then that is the main problem with the public level. But if it is a personal thing, and if the persons are very interested, for example, in NEGOMBO area, I did number of systems for school teachers in Masla College, then they are doing well. They are working with the system very successfully. The interest should be there. If there is no interest, then for example, in my house also, I am the person putting my interest to the system. The other people doesn't want to look into that. They are getting the gas only. Yeah.
There's a question from a participant about the carbon savings, whether you have calculated the carbon savings from this capturing the methane, especially this with regard to climate change impacts.
Yeah, actually that it comes with the big system. For example, in 2018, I get that Green World Award. Green World Award gold as a gold winner. There I present how much of carbon dioxide saving with my system. For example, when we think about desiccated coconut meal, with the capacity of 20 cubic meter of wastewater per day, then how much of energy we need to have to treat that water with the conventional system. Actually, for DC means there is no conventional. Then we can think about the hotel. For example, Hotel Eden and Spa. It emits about 120 cubic meter of wastewater from the 168 rooms. Then to treat that 120 cubic meter of wastewater, how much of energy you need to consume per day? Then say about 100 kilowatt hours. Then to generate that 100 kilowatt hours, how much of thermal power is needed? For example, in Sri Lanka, only 30% hydropower is available, other 70% is thermal power. Then while producing 1 kilowatt hour, with the thermal power generation, how much of carbon dioxide emits to the environment? Those data are available in internet, and we can calculate all those data, and we can calculate with one system how much of carbon dioxide we can save per day, carbon dioxide emission, rather than using that conventional system. Then I have calculated all my projects during last number of years. Then all the projects control the carbon dioxide emission is about 79 tons per day. That means when we consider all my projects, it is about, I couldn't remember, 120 projects or something. Then altogether, the saving of carbon dioxide, instead of using conventional system, is about 79 tons of carbon dioxide per day. Then due to that such saving, I got the gold award from that green, the Green World Award from UK. Yeah. Actually, we have to do a perfect calculation. Perfect. Otherwise, they are not believing. No. We have to give all the websites. We have to give all the links and how I get the data and how I get the calculations and everything. We have to present. Yeah.
There's one question in the from a participant, whether at household level, whether it's possible to generate gas with only kitchen waste.
Kitchen waste means that you mean solid waste, no? The kitchen waste water.
Yeah, only waste. Kitchen waste and not using the toilet waste. Only kitchen
no,
waste.
It can, but the kitchen waste is very small and there are pollution. It can, but there are a lot of problems. For example, in my system also, I am putting a lot of solid waste from the kitchen also. But once it mixes with the sewage, then it emits huge amount of biogas. Because sewage having enough anaerobic bacteria also. And every day you are having an input of bacteria instead of feed also. Then due to that, the production of biogas is very high with the sewage. But kitchen waste and kitchen wastewater alone also you can. For example, we have done number of systems for the catering people. In catering, you are having a totally kitchen wastewater and kitchen solid waste. then they are getting the gas also, no problem. We can do, but for a household, the kitchen wastewater is very small. And solid waste also from the kitchen also very small. And due to that, the amount of gas what we can obtain is very small. Then maybe it is not sufficient for the whole cooking. Maybe very partial cooking can be done.
I think now we have spent almost 1.5 hours on this very interesting, very topical and elaborative topic. And I'm really thankful to all the participants also for showing their interest, joining the webinar, and asking questions, which made it very live. So on behalf of the Institute of Environmental Chairman for agreeing to do this, share your knowledge through this webinar, which would benefit a wide number of people in the country as well as abroad. And also we are very proud that you have really won a lot of awards on behalf of the country for this green technology, which really needs to be promoted much more, as we all agree. And so finally, dear participants, we would like you also to be members of the Institute of Environmental Professionals, if you like. And also we will update you on the future webinars and future activities of knowledge sharing that we organize in the future. So I would like to request Mr. Trishant to put that slide about our institute so that, you can visit our website and get more information.
Thank you very much, Mr. Jayamanne.
Okay, thank you very much for you all, especially the Institute of Environmental Professionals, especially for Professor Hemanthi and President and other office bearers who helped for this knowledge sharing webinar. And I would like to send my special thanks for you all.